AP Calculus students. We are working on section 2.3, product and quotient rules of differentiation. These are the notes that you need for section 2.3. Following this video, we're going to do the examples in this video for 2.3a. You have an assignment for 2.3b and c, and so there will be an example video for the examples for 2.3b and c together. So there's two videos for this section. Let's do these notes. First of all, the product rule of differentiation says, like my color coding, that if you have a first function times a second and you're taking the derivative of it, this is the formula to do that. It is not the derivative of the first function times the derivative of the second function. I can see where you might think that would work because it's worked kind of in that way for other derivatives. This is not true. We will look at the proof for these formulas on pages 119 and 121 when we are together. So the product rule says take the derivative of the first function times the second plus keep your first function and multiply by the derivative of the second. And when I do this product rule, I kind of talk my way through it like that. So let's connect the power rule to the product rule using this example. Suppose you have the function h of x, and it's 3x minus 1 times x plus 2, and we want to find the derivative. One thing I could do is using the power rule, I could rewrite this function by multiplying it out. So I'm just going to do that first. 3x squared plus 5x minus 2, right? And then I could use just the power rule to take the derivative of this function, which you would tell me is 6x plus 5. Let's go ahead and use the product rule, where 3x minus 1 is the first function and the x plus 2 is the second. F and g, talking my way through it. I take the derivative of f times g plus I keep my f and multiply it by the derivative of g. I'm going to do some distributing here. 3x plus 6 plus 3x minus 1, and we get 6x plus 5. Notice you get the same derivative. Let's look at the quotient rule. If you have a function f divided by a function g, it is not the derivative of f divided by the derivative of g. It is this formula here. Take the derivative of the numerator times the denominator minus, keep your numerator, times the derivative of the denominator divided by the denominator squared. So let's connect the power rule to the quotient rule. If you have the function h of x and it is in the numerator 3x cubed plus 2x divided by in your denominator x, let's find the derivative. So by the power rule, let me first set up this function so that I can use the power rule. I'm going to divide each term in the numerator by x, and I get 3x squared plus 2. And then when I take the derivative by the power rule, I get 6x. Let's go ahead and use the quotient rule, where the numerator is here in f and the denominator is here in its g. Let's talk our way through it. The derivative of the numerator times the denominator minus, I'm going to keep my numerator and multiply it by the derivative of the denominator all over the denominator squared. Let's do some distributing. That would be 9x cubed plus 2x minus 3x cubed plus 2x all over x squared. And let's clean up that numerator a little bit. 9x cubed minus 3x cubed is 6x cubed plus 2x. That was supposed to be a minus 2x. Sorry about that. Here we go, minus 3x cubed minus 2x. I did that so you remember not to do that. I'm just joking, that was a mistake. And then divided by x squared. And notice x cubed and x squared cancel and leaves 1x in the numerator and we get the same answer using 6x. Notice the quotient rule seemed a lot more complicated than the power rule. That's not always true. I just wanted to prove that you get the same answer. So you may say then, why do we need the product and quotient rule? Because what if you're asked to find the derivative of h, and h is x squared times sine of x? Notice I cannot simplify this in any way to use the power rule. Gotta use the product rule here. Or if h of x is cosine of x divided by x cubed plus 1, again, notice I can't simplify this in any way so that there's not a quotient. I have to use the quotient rule. Let's take a look at number 4, higher order derivatives. You know a first derivative is f prime of x, and the second derivative then, it makes sense, is f double prime of x, double quote mark there, or using what's called Leibniz form, d squared y divided by dx squared, and the way we say that is the second derivative of y with respect to x. The third derivative then would have 3 single quote marks, or d cubed y divided by dx cubed. Again, we would say that this is the third derivative of y with respect to x. So what about applying derivatives to physics, really, is what we're applying it to. So if you have a position function s of t, the book and the AP exam also uses x of t and some other forms. If s of t is a position function, then the rate of change in your position, which is a derivative, the rate of change in your position, we call that velocity, right? So if at a time 0 you're at mile 0, and 100 miles later, it's 2 hours have gone by, you would tell me your velocity was 50 miles per hour. That is a rate of change of your position. So the first derivative of a position function is velocity. What if you have the second derivative of the position, which is the first derivative of velocity? The rate of change of velocity is called A of t. It's called acceleration. You probably remember this from physics. Again, number 6, looking at the proofs of rules on page 119 and 121. We'll do that together in class. Number 7, just wanted to make the point that, again, it's not the calculus, it's the algebra in these cases. When the textbook gives solutions, or the AP exam does, they often use greatest common factors and common denominators. So even though you can go ahead and do the calculus, the form that you have your answer in is not the same as theirs. And so I want to make sure you can produce equivalent forms so that when you're checking your answers or when you're on the AP exam, especially if it's multiple choice, you could find the right answer that matches yours. So here's what we're going to do. Basically, whenever we do product and quotient rule, we're going to do all of our calculus, all of our operations. We may break our answer into smaller terms and write our exponents as positive. Find a common denominator if necessary. Again, it's the algebra, not the calculus. Let's try number 39. So if you've been given the function f of t and it's t squared times sine of t, and they want the derivative. Notice what I have here. My first function is t squared. My second is sine of t. This is a product. I'm going to use the product rule to find the product, the derivative of this expression, talking my way through. Here is f, here is g. I take the derivative of f times g, plus I keep my f and multiply it by the derivative of g. There we go. Perfectly correct answer. You would see on the AP exam or in the back of the book though, as I indicated here, they use greatest common factors a lot for good reason. Sometimes we factor these expressions and set them equal to 0, and if they're factored, they're easier to solve. Notice there's a t in common as a greatest common factor in both terms. There we go. So you may see an answer that looks like this. Number 41, Let's say they ask you for the derivative of cosine of t divided by t. So I'm going to go ahead and start that here. Talking my way through the quotient rule. Here's f, here's g, numerator, denominator. I'm going to take the derivative of f times g minus, I'm going to keep my f and multiply it by the derivative of g all over g squared. Okay, be a little careful here. Notice that this is not sine of t squared. This t is multiplying the function sign. So just to be more careful, I'll put it in front. Negative t sine of t minus cosine of t over t squared. Final answer. Just so you know, the book factors out a negative because it's in common in both terms. I don't feel it's necessary to do that. Let's look at two more. Number 4 and number 33. All right, let's see what number 4 says. In number 4, they are asking for the derivative and they want you to use the product rule. They have g of s. I'm going to use an x. My s's look like 5s and I don't want to confuse you. Like I haven't confused you already, right? There we go, square root of x and x squared plus 8. Okay, now they want you to find the derivative here using the product rule. I just want you to know I wouldn't use the product rule. You can. Here's your f, here's your g. You can run through the product rule. To me, this is so easy to simply distribute the square root of x here and here that I think I'd rather do that and use the power rule. Okay, now, so let's go ahead and do that. The problem for students, whether you distribute now with the power rule or the product rule, is what is the square root of x times x squared? Well, no matter what, when we take the derivative, we need to see some exponents. So the first thing I'm going to do, all I'm going to do is write the square root of x as x to the 1/2. That's all I changed so far. And now let's go ahead and distribute. Notice I haven't put a derivative sign on the g of x yet. I haven't taken the derivative. I'm just fixing g of x so it's easy for me to take the derivative. X to the 1/2 times x squared. This is actually an exponent of 4 over 2, right? 4 divided by 2 is 2. And now I can add these exponents. I have x to the 5/2 plus, and when I multiply x, 8 times x to the 1/2. I'm finally going to take the derivative using the power rule. I'm going to bring my exponent out front and multiply it and reduce the exponent by 1, which would make x to the 3/2 plus, I'm going to bring my exponent out front and multiply it. 8 times 1/2 is 4, and I'm going to reduce my exponent by 1. That makes a negative 1/2. Now, this is perfectly correct, a perfectly correct answer. However, this is not how it looks in the book or on multiple choice on the AP exam. Let me point out, if this was free response, you would be done. It would be their job to see that your form of the answer is correct and compare it to theirs. However, if this was multiple choice, here's what it would look like. First of all, there wouldn't be this negative exponent. Here's what they would do. I'm keeping the first fraction the same. The second fraction, I am going to write with a positive exponent. This answer is true also. However, it's not what it would look like on multiple choice on an AP exam. Now that I can see this x to the 1/2 is really in the denominator, I'm going to get, I see I don't have a common denominator, and I'm going to get one. So I am going to multiply the top and the bottom of the fraction here by x to the 1/2, and the top and the bottom of the fraction here by 2. Notice I now have a common denominator. of 2x to the 1/2. Let's do the math in the numerator. 5, when bases are the same and they're being multiplied, you add the exponents. 1/2 plus 3/2 is 4/2, which is 2 plus 8. And this is the final answer they would have on the AP exam, or they may show it in radical form. Why do they do this? They do this because if you were to go from here and set this equal to 0 and solve it, it's much easier to solve in this form than in this form back here or this one. Okay, number 33, and then we are done. Let's see what, of course, they want derivative on 33, I'm sure. Let's see why I thought that one was important to show you. Number 33. All right, let's take a look. 33, oh yeah, f of x is 2 minus 1 over x divided by x minus 3. And they are asking for the derivative here. I just want you to know in this one, you can use the quotient rule, of course, right? F, G, run through the quotient rule. This will get a little messy right here, right? We're having two different terms in the numerator, and not only that, that there's a fraction in the fraction. And so I just wanted you to know what I tend to do is I like one numerator and one denominator. Notice I wrote f of x, not the derivative. I'm gonna fix up this numerator a little bit first. I like one numerator. There we go. So I am gonna multiply the top and the bottom here in the numerator by x, and I now have a common denominator in the numerator. So here we go. I have x is the common denominator in the numerator. My new numerator is 2x minus 1. There you go. If it's okay with you, rather than dividing by x minus 3, I am going to multiply by the reciprocal. There we go. Still not taking the derivative, just setting up to do that easily. And I will distribute the x and have an x squared minus 3x. Okay, I'm now going to take the derivative. And I'm going to talk my way through the quotient rule. Here we go. I'm going to take the derivative of f times g minus, I'm going to keep my f and multiply it by the derivative of g. Just checking, make sure I did it right. All over g squared. There we go. Let's fix up that numerator. I have a 2x squared minus 6x. Okay, notice I'm going to multiply this out, and then whatever answer I have, I'm going to take the opposite of it. 2x times 2x is 4x squared. Now it's negative. On the outside, negative 6x, negative 2x for a negative 8x. Now it's positive. Negative 1 times negative 3 is a positive 3. Now it's a negative 3. There we go. I think one more step, and we're good. Let's take a look. Collecting our like terms. Negative 2x squared minus 2x, minus 6x plus 8x is a plus 2x minus 3 all over x squared minus 3x squared. Again, it's the algebra, not the calculus. So just wanted to show you that sometimes it really does help to fix up a function before you use a product quotient or power rule, and you really just have to be really careful with your negatives in distributing here. You saw me make little tiny mistakes and correct myself. It's okay. It happens all the time in math. This is our video for the notes for 2.3, the examples for 2.3a. There will be one more video on examples for 2.3b and c together. Have a great day.
Have a great weekend.